Okay, this should be pretty quick. A little bit of monkeying around with our properties. Okay, I knew Kate was doing the thing. Wait. Jacob, are you the only one leaving? I thought we had more track people in here.
Yeah, it's not running.
It's just a field guide.
Yeah.
Oh, okay. So it's just the cool kids.
Yeah. The non-runners.
Yeah.
Hey, if you can't row with the best, you gotta run with the rest, that's the saying.
Hey, you can get out of those.
All right. Get the thing done.
All right. Yeah, just my notes. Okay. Yeah.
What's the weather today? Am I supposed to blizzard?
We're only supposed to get an inch or two tonight. It's no big deal.
I wish there was snow.
We get 50% on this. Mary, his cousin.
I take all the verbalization to mean that everyone is finished. I heard one squeaky little no in the middle of all that.
I'm ready.
Oh, shoot, ready.
After that, it's not good.
Hola.
What's up? I couldn't remember if there was 5 or 6 sections in this.
There you go.
Cool? Alright. So, my log properties are all about factors. If they're all about factors, then I want to make sure that, come on, Frank, I break things into prime factors whenever possible, like so. If I say log of this and log of that, I want to switch those 32 and 9 into powers. Then, break them up is nice and easy. If I have a quotient as an object of a log, I can turn that into a difference of separate logs. So I say log of 2 to the 5th minus log of 3 to the 2nd, and then exponents can become coefficients by the power property. For our expansion, honestly, that one was practically expansion anyway. Hopefully we didn't get caught. How many of us made the whoopsie of 4 times m cubed times n to the 5th and said ln of 4 plus the ln of m, 3 comes out front, plus the ln of n, negative 5th, and then negative 5 comes out as a coefficient. And now you're wondering why he said, uh-oh. Okay, we break them up by prime factors. I can't leave that as ln 4. I need to turn that into 2 squared. So that's the ln of 2 squared. I'll put my 2 out front. Plus 3 ln minus 5 ln. So, what I'm looking for is, did you have the correct power breakdown? Did you remember to put your coefficients out front and say minus? Did you have the correct term here, term here, term here? There we go. It's like if you just goofed that ln of 4 instead of 2 ln of 2, one off. Probably the most common error in the room. Whoopsie. Feeling okay about yesterday's stuff? Those of you that actually did the assignment, tried to throw a little bit of spice in there. And, well, there was things like irreducible quadratic. Like if I had x squared plus 5 in parentheses, you can't break that up. It's going to result in imaginary factors. So you just leave it like that. So just seeing if we could take what we did yesterday and bring it to the next level. Anyone who has questions, I assume, is going to ask questions. So I said 3-3 and 3-4 are typically like day and a half each. Today will be combination 3 and 4. Tomorrow, finish off section 3-4. And then theoretically, we have our test on Monday. Oh, yeah, Tuesday. Oh, that's right. That's why I was looking at the front there, because we would actually finish all of chapter 3 and then do our quiz. Problem with that.
I love snow. I hate snow. I think
Oh
snow
my
is I love it.
Okay.
And it's just like
You also need to understand that right now you are at 6 days 6 snow days, and there is only 5 built into the schedule, which already pushes everything back 1 day. That means right now, students' last day is Friday, May 26th. So we've already had to push things back. Because of the high school final schedule, be prepared that that might do things. That might take all 3 finals days and put them after Memorial Day. Your last day would be June 1st, yes.
Oh, that's not bad.
I thought it was in Colorado.
I think
Okay.
it could be worse, guys.
Also, because Snowmageddon, that like 4 or 5 days straight in December, was statewide, it's also a possibility that that gets the governor exemption. Sometimes when you have just too much weather event, the governor of a state can excuse certain days under executive order. And I've seen it happen before. Basically, Christy would say, don't worry about those 4 days, you're good.
First semester.
Okay. It's still part, like there is a legal requirement of minimum contact time for schools. You have to have X amount of hours over the school year contact with students. Like that is part of our state law. Every state has that law. I'm just letting you know that's what's coming. There's potential for things to get wild. Okay? There's potential to mess with the end of year schedule. So I'm just letting you know it's a thing. Spearfish is supposed to get another foot and change. And it seems to be going up because yesterday it said 9 inches. So I'm just letting y'all know because I like kids to be informed about stuff. All right. We did expansion stuff. We weren't really a fan of it, but I think we got it. We started doing condensing, and just be careful that sometimes if you end up with a radical on denominator, then you do have to rationalize for your final answer. So I think we did part A. Okay, so every morning. We'll do part B just as the refresher and then set you loose. If I'm going to condense things, I have to make sure that it's log of object. I can't have anything else there. So coefficients in front of the logs, I've got other stuff there. I need to get rid of the coefficients first. So we use our power property to turn that into the ln of x minus 4 to the 6th. Turn that into ln of x to the 3rd. And then we have our product property that says if I have separate logs of the same base added together, I can just do a single log of a product. This times this. I'll write it in this order just because usually we put something in front of parentheses. Can I distribute that x to the 3rd into the x and the minus 4? How many x minus 4s are there? So if I distribute an x to the 3rd in there, that means I'm multiplying by x to the 3rd 6 times. Okay, so like you picking up what I'm saying here, that's a x to the 3rd by x minus 4 by x minus 4 by x minus 4. If I try to distribute this, you're giving this to every single one of these binomials. Okay. Now, like Holly said, Yeah, maybe I have x minus 4 to the 5th and only distribute it into one of them. All right, that's a thing. Will I end up with more terms or less terms if I do that? More. What are the directions? Condense. You done. I'm just telling you, you can't distribute into that because there's 6 of them. Okay? It's a really common mistake to want to distribute into that. So, you got your properties. We've already done the expansion stuff. Now it's just go in reverse. We give you big ugly thing, turn it into a thing. Okay, condense them using our product, quotient, and power properties. Now remember, you can talk to each other about math at one general vicinity of the room.
Talking about UConn.
I don't think so.
Okay, just, this ain't a daily quiz. It's not your weekly quiz. It's just do the thing. Check with your neighbors, make sure that everyone's kind of on the same page. Does that negative mean that I just have a negative, or does that negative mean it's going to a denominator? What? Yes. If you have negative exponents, you do want to write those on the denominator. By the time we're done with this, we should not have negative exponents.
I don't know. Wait, that could work. I don't know if it will. This is what it's not. I've been waiting to see like minus.
This is how we get points.
Yeah. Or maybe put this in there, so one up there. No, I don't think so. No, because I would turn that. No, it wouldn't.
it's not.
I don't know. Where's your two? It's supposed to be 3. 6x to the square.
It kinda looks like a brownie point to me.
Uh-huh.
Negative 5. Yeah, it's also supposed to be negative.
Wait, can you do that? Oh yeah, because then it's just on the denominator.
Oh,
That's
yeah.
easier.
Factual.
That makes so much more sense. Yeah, sorry. That was so
Okay.
annoying.
So I'm just saying, do you see how those are two different terms? You can just rearrange them like this. Okay. Whether you put the negative 5 up in the exponent, but then negative exponent means it has to go to the denominator anyway, or just leave the negative there so you know it's going to be a quotient. Same difference. When you condense that, actually apply that 3. What's 6 to the third? Boo.
36 is 186.
200. It's like
You like missed an entire 30 there. 216. 216 x to the third over x plus 1 to the 5th. And again, the textbooks will usually not have this outer set of parentheses. They will just say log base 2 of that. No parentheses. I like putting the parentheses on there because otherwise I'm going to think that's 2 times this binomial. Okay? So it's not necessary, but you're also not wrong if you put them there. We seem to have a little bit of trouble With multiple things on denominator yesterday when we were expanding, just look at their signs right now. Will the first term be on numerator or denominator? Numerator or denominator? Okay, so both of those go to the denominator. Anything that's subtracted means it's going to have a negative exponent. If it has a negative exponent or subtracted, that just means denominator. So that's the ln of a 3x plus 5 goes upstairs. Put that 4 up top. That's a x to the 4th and a x minus 1. Can I distribute the x to the 4th? Now I can, because there's only one of them. It's only an x minus 1. It's not an x minus 1 to some other power. So I can distribute that. Will that result in something that is more or less condensed? Not only will there not be parentheses, but I'll be down to 2 terms there instead of 3. So I should probably do it. Okay? Because I can distribute and because it results in a more condensed expression, I should probably do it. But if that was x minus 1 to the 3rd, then I can't, because there's 3 of them there. You would be multiplying 3 times, and that's not fair. Oh, interesting possibility. What if I had ln of 3x plus 5 over x to the 3rd by x minus 1? What if I had that? Can I distribute? You can, but you got to wiggle it a little bit. See how they're both to the 3rd? You got to wiggle it a little bit. It's like, can you actually get this couch in your bedroom? Got to wiggle it a little bit. Okay. Well, it would allow me to do x to the 6th minus x to the 3rd, getting 2 terms instead of 3 terms. Because this is x squared and this is x, then both of them to the 3rd. Like, it's not necessary. I'm just asking, is that legal? Okay. You don't have to do it. I'm just asking, is it legal? Could you get away with it? So, condensing, a lot easier. Let's do something that's got some more terms to it. Something bigger and chunkier. Let's do something that's got extra powers and something that's got more terms. 12 and 15. I want to do a little more. The look of just pure resentment that comes off of someone's face when they see a radical on denominator. And we'll see who gets 12 all the way right. Who's going to remember the cherry on top? Loggy! He's my little buddy. Do you really?
Yes. You have to get the radical out of the box.
So there's more than
Oh, that's just the whipped topping. That's not the cherry on top. You do have to rationalize the denominator, yeah. Continuing our near semester long trend of just taking Algebra 2 and dialing it up to an 11. It's next chapter that we get brand spanking new stuff. No, it is. Like, it's the trig chapter. It's the thing that legitimately prepares you for the next class.
Yeah, we missed like all the trig stuff.
Yes, I remember that.
She did not know what.
Yeah, the one with things she have glasses.
Yeah.
Yeah.
She can do. She always uses the wrong one. She like you're supposed to use sine. She used like cosine. Or like. She,
Yeah.
She mixed up.
She was great. She was great.
If it makes you feel better, I heard Miss Work also complain about that person a lot. I guess it was not a good experience for anyone. What do I got to do first?
You have to put exponents.
Okay. Exponents from the coefficients. You come up here, you come up here. Then I have log of a thing minus log of a thing. What do I do with that? Okay, a difference of logs of the same base can be written as a log of the quotient. So now it's going to be log base 2 of this guy up top this guy downstairs. But when I do, I'm going to write it as a radical because anything to the 1/2 power is square root. And ruh-roh, Raggy, no radicals downstairs. So if it's a square root, that means I need 2 of these things to get out of radical town. So I'll just multiply by the exact same thing. And then simplify. Log base 2, I say simplify, but it actually looks more complicated. 5x plus 6 to the third by square root of x minus 4 all over x minus 4. There's one tiny thing missing. We're missing the cherry on top. Oh, I don't want to distribute there. Oh, no. Also, we can't distribute into Oh, no. You,
You know what
okay,
I'm talking about.
I know what you're talking about. We're just losing the word. Okay. The means
No, you didn't.
absolute value brackets.
Oh.
Remember? Light side, dark side? When we were solving them?
We don't like to do that kind of.
I just took this expression out of an even radical. That's x to the odd power that came out of a even radical. I need to make this positive because it's a logarithm. I can't take log of non-positives. To ensure that this is still a positive thing, I need absolute value down there. Yes, ma'am.
Okay, so what if you, in the scenario that, say it was like 5x plus 6 squared or something like that, what if you like distribute that out and then it would cancel with x minus 4, like one of the factors? Like if that scenario wouldn't, but what if it did?
I would need to see it written. I'm losing the words.
Like,
Which means like, what if like the factors of the 5x plus, or like whatever would be up there cancels out with the x minus 4 on the bottom.
yeah.
Mmm.
Is that like a possibility or is that never gonna happen?
Well, that can happen. It's math. Anything can happen.
Well, imaginary.
Hmm.
I don't think they should.
I would have to play with that. That's a good one. What if that x minus 4 on my denominator ended up as a 5x plus 6? And they were able to cancel. I'm going to have to take that into account if I'm restricting my domain, but I don't think I would need absolute value in there anymore. Because we didn't need it when something similar happened earlier in the year. But I'd have to play with that. I don't know for sure. That's a good one. Okay, what about the other guy? Because we had something similar. We had a radical. This guy comes up here. And then everything that's positive goes upstairs. Everything that's negative goes downstairs. Getting log of 3yz squared over what kind of x? It's a cubed root. And we can't have that. So what do I multiply by to rationalize it? You can't just do cube root of x again. I need 2 more x's to get out of that radical town. So I can either do the cube root of x squared, or I could just leave this as x to the 1/3 and multiply by x to the 2/3. So same difference. Third root of x squared. Color. So we got log of 3. Should we write that as x to the 2/3 or leave it as a radical? It really is. No, look, I'm serious. There wasn't a right answer. There's not a right answer there. So yz squared, and then if you want to write cube root of x squared like that over x. Do I need those absolute value again? It was an odd root, so no, I do not. Okay. All right, I think we've just nicely beat those into submission. Moving on to change of base formula. Okay, this is the one that, if you remember there being a log over a log, the proof for it is really simple, but it's something that we might not think of if we're trying to do things ourselves. So say I got log of b, log sub b, log base b of x. I can choose to multiply this by any log that I feel like. So long as thing over thing, if I got like 5 over 5, if I got log of 3 over log of 3, it's always 1. So if I were to multiply this by log base c of what variables do I want to use here? No, it's got to be b. Yep. I forgot the reasoning behind it until just now, but log base c of b. Okay. So you choose log of any base that they have in common, and you can choose whatever you want. You can use common log, you can use natural log, you can use log base 2, you can use log base pi, as long as it's the same. And, well, those two things, the orange thing's got to be the same because then you're multiplying by 1. Now, right now, you would say, why did I do this? It looks so complicated until this is a logarithm. This is the coefficient of a logarithm. What can I do with coefficients of logarithms? They can go up to exponent town. And what did we say happens when the object of the log and the base of the log are the same? They cancel, so all this goes away, and that x comes down here, turning it into log base c of x over log base c of b. So that's where that change of base formula comes from. How many of us would think of using that entire thing as a coefficient and exponent? Okay, it's pretty abstract. But what it means is if I had something like log base 3 of 5, y'all, older calculators didn't have a log base button. So I would just do log of 5 over log of 3. I would choose to use the common base. I do base 10 for both of them. It's log of some base of the object over log of some base of the base. In this case, I chose common. I chose base 10. This is going to be the same as if I did the ln of 5 over the ln of 3. It's going to be the same as if I did the log base 7 of 5 over the log base 7 of 3. They're all going to give me the same value because of the change of base formula. Now, we're typically going to use the first two because we're not facetious. Well, I am. The first two are buttons on my calculator. All the way back to scientific calculators in the 80s, they had log buttons. Okay? And just to show you, if I had alpha window, what option is it? 5? So if I did log base 3 of 5 versus I did just plain old log of 5 divided by log of 3 versus I did the ln of 5 divided by the ln of 3. Okay? The change of base formula allows me to stick with the 1 or 2 buttons that are on every calculator. Okay? This is also how on older calculators, on an older calculator, if I wanted to type log base 3 of x, I just plain couldn't. So what we would do back in the day is instead I would parenthesis, and I'd say the log of x and I would divide it by the log of 3. I suppose I didn't need that first set of parentheses, but you get the idea. And now I should see the exact same graph. Okay, so this is the ancient magic. So if you got a log base button, the only reason you have a log base button is it's just doing the change of base formula in the background. It's really easy to, oh Jesus, I didn't even know that it was 3 and 5.
That's funny.
All right, well that's about 1.4 something. So whatever the decimal was.
We're supposed to do this.
We will do approximately because these are not rational values. 1.465. So I would do log of 5 over log of 3, and I'd say it's about 1.415. For this, I would choose whatever base I want. I'll tell you that the book really likes using natural log for everything. The book, like the solutions to these, they love using ln for everything. I'm not sure why, because it is a personal preference. You could choose to use log base square root of 6 if you wanted to every time. Well, that kind of defeats the purpose because you're using the log base button to not use the log base button. But, yeah. Because you can choose. As long as you're using the same log, numerator and denominator, you get to choose. This is the exact same as log of 6 over log of 1/2. They are the same. What one's that? Okay. So that's it. It's just a formula, plug and chug. It's kind of redundant for us because we have a log-based button in the year 2023, but I'm still going to show it to you. Okay. So this is probably where we remember log over log from last year, was change of base formula. All right. Take a wild guess what the word problems are like. Like, blah, 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 shove this in for A, shove this in for B, hit buttons on your calculator. To which I say, blah, 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 put it in your calculator. Like literally the word problems are just, they'll give you a formula that happens to have a log in it. Okay, go shove these numbers in that formula. Y'all know how to work with formulas. You passed geometry. So I'm not very concerned about that. So we'll just move into 3, 4. 3, 4. Okay, one-to-one property of logs and exponents. We've already been using these, and they're kind of the duh of math. You would think it's just logical. If I say, damn it, Frank. No, don't put that. If I have 3 to the x equals 3 to the 5, just logic dictates 3 to this thing equals 3 to that thing, those things better be the same. It's like the substitution or transitive properties. Right? Remember, if A equals B and B equals C, this is the transitive property. If A equals B and A equals C, B equals C, that's the substitution property. It's just whether you have to cross the equal signs is different between substitution and transitive. Literally the same thing, right? Because then you also had the, what was it? Something property of equality. That allows me to switch this to C equals A. Like, this is bare bones beginning geometry. Remember when you were doing the axioms that are just like, friggin' look at it? Okay. But here's why it works. And I want you to write this part. If I have 3 to the x equals 3 to the 5th, the reason this works is because I can log both sides. If both sides have a base of 3, it makes a lot of sense for me to use what kind of log? Log base 3. So I would log base 3 of this guy, I would log base 3 of this guy. Well, what happens is that x comes out front, that 5 comes out front, and now I have x log base 3 of 3 equals 5 log base 3 of 3, and what is log base 3 of 3? 1. So I get just x is 5. So we can look at it and just logically think, well, this has to work. But as many of you are going to be adults very soon, you should know it's not what you know, it's what you can prove. Okay. Oh boy, do I have an anecdote for that, but I'm not supposed to. No. Like it's actually a binding legal agreement, I can't. So, same thing goes for logarithms. If I said log base 2 of thing equals log base 2 of other thing, then it should make sense that thing equals thing. But, here's what I do is by definition. Remember, if I have log base b of x equals y, b to the y equals x. So if that's my definition, really? If that's my definition, then that means 2 to this thing equals x. If b to this power makes x, then 2 to this power makes x. That's exactly what I'm doing, but twice. If I have 2 to the log base 2 of 6 equals x, remember the property. If the base of the exponent and base of the log are the same, my property says cancel town. Okay? So I can just look at it and say log base 2 of this equals log base 2 of that. This must equal that. Logic. But this is the proof. This is why it works. Okay? It's just by that definition. So, equation time. Well, I can't use the one-to-one property on this. They're not the same base. Or are they? Right? Because this isn't just 36, this is 6 squared to the x plus 1 power. And what do I do with an exponent raised to an exponent? Multiply. So I don't need you to show the whole logarithmic version of this. You can just use the property. Just like after you learned angle side angle, you didn't have to keep proving it over and over. You were able to just say angle side angle. So one-to-one property of exponents now says 2x plus 2 is x plus 6. Now we get equations like we're back in algebra half, pre-algebra. Subtract x, subtract 2. I win. Now, if I want to check this, the easiest way that I could think of is I'd grab my calculator, I'd put a 4 here and a 4 here. If these two sides are equal, what would happen if I took left side minus right side? This is going to come in really handy when my answer is nasty. Right now I can just type a 4. But if I had 4 was my last answer, I can now say 36 to the my answer plus 1 minus 6 to the my answer plus 6. Oh, plus 6. There we go. And if I'm right, da-doop-a-doop. Okay, I'm showing you the answer button because we are in this section going to get answers that are non-rational. My answer might be 3 plus 1/3 e all over 5. Well, that's not a rational number. It's nasty. If I want to check my answer, using answer button would be pretty handy. Okay? What about the other one? Those aren't the same base either. They can be. Because 1/2 is 2 to what power? So this is 2 to the negative first. 64 is 2 to what power? Yes. Someone actually tried instead of just saying numbers until I stopped you. It is 2 to the 6th to the 1/2. One-to-one property says 2 to the thing equals 2 to the thing. Negative c is 3. C is 3.
She's negative 3. That's okay.
No, that's 2. That's 2. Ressa. Well, the Three Stooges are missing a head, so tends to tone things down. All right. You know you can just do that, right? Yo, food. I said I had for years, like I had all 3 of the Murray girls, one after another, and they all just sat here first hour, Algebra 2 or Pre-Calc, mowing down a bowl of Reese's Puffs. Kept their milk in the fridge, kept their cereal and stuff in there, and they just ate cereal in here every morning. I don't care. Do it. I had one kid who kept miniature pancakes in here. He just straight up had pancakes during pre-calc. I don't care. As long as you're working, I want you to feel comfortable. Okay? All right, A and B. Hey! A and B. On B, be careful. How are you going to write them in the same base? Okay. How do I flip things? Oh, and I'm going to have a little bit of time during second hour again today. So again, if you have any notebooks that I need to go through and try to prioritize those. I'll be honest, yesterday I didn't just because the magic announcement stream for the next set came out, so I was watching that.
Nice.
Oops. Do not guess it. You better know your powers of 2 and 3, and they're flipped. How do I flip things with exponents?
Oh, you just do negative.
There you go.
So negative
So if it got
2.
squared and it got flipped,
Negative 2.
-2.
For the 9/4.
Uh-huh. I'm betting most of us didn't go to powers of 2 on the first one. Did you get the same answer? Right? Whether I call this 4 to the second is 4 to the 4x plus 7. If I get 2x plus 6 is 4x plus 7, or if I do powers of 2 instead, see that they're the same thing? Ruh-roh. Probably just missed a sign or distribution.
This is a 6.
Yep. Found it. Okay, so those ones are easy peasy. But this one, I got to do some thinking. I need to have them in the same base to do the one-to-one property of exponents. I need to write this as 2/3. I know that. So the question is, how do I turn 2/3 into 9/4? We squared them and we flipped them. So -2 is my power. Then we go one-to-one property. Get x minus 5 is a -3/2 x. Subtract. -5 is -5/2 x. Divide. X is 2. Okay. So the solving of them is kind of just basic, old school, helping your younger sibling through middle school math algebra. But it's getting there and double checking how my exponents work that we got to be careful about. Yes, ma'am.
Are you always gonna try to make like the higher base lower? Like the greater base smaller?
What if you got to meet in the middle?
Oh, that would be sad.
Oh, oh boy. They want to go all the way over here? No, that's too much. Somewhere on here, you're going to have room. If you don't have room, make room. What if I did go?
I have a question.
I crashed twice in like span 3 weeks, but I haven't crashed again. So, and now I'm better.
This is really great.
This is why teenagers have higher car insurance rates.
My parents don't have good insurance, so okay.
Pretty sure I'm listed.
Get them? How are you going to write 25, 64, 512, and 125 as the same base?
I don't even know how we flip stuff.
So there's got to be a negative exponent somewhere to flip them, but what's the base? If only we knew our squares through 20, cubes through 10, fourths through 5, as many powers 2 and 3 as we can memorize.
It's not just like 5/2.
Oh, I'm supposed to do.
Tonight, it's supposed to be like 3 inches. It's not a big deal.
So then like next week.
Between Monday and Tuesday, right now it's like 14 inches.
So they can get this how just like up out. So we'll just have like a late start.
Also, I've heard that rumor 3 times now that Spearfish has run through its snow removal budget. So don't expect that things are going to be cleared in a reasonable time frame.
My crap was on the floor, and I told him about that because you said something about it, and he's like, "Yup."
My house is on fire.
So you win?
I went, yeah, I think it was
Just a little bit.
I found it next time. I know.
The two different things.
I know, but I forget that like the only people that I know where they live can kind of sound creepy.
I know so many people live on accident.
Same.
Like they're baby. They're figuring out they're just
That's fantastic.
or they Sean.
Do math!
I can't process my brain.
It happens. I suppose I should probably check in on Grandma anyway.
My grandma my great grandma. I don't like her. I mean, 13. I really went to her house and she made me do all her chores.
Yes, ma'am?
Is this like in here? Okay, that was odd.
But you turned that in. I just might have not put it in chapter 1. No, I don't have the chapter 1 stuff. So I need to see that. Yep. You got the chapter 1 packet too.
Huh?
The packet and the notebook. I need both. And if you just leave those here at the end of class, I will get those done while the next class is testing.
Because I didn't realize it until last night, so I'm not great.
So chilly in here.
If it's chilly in here, can I say that it's enchilada next door?
Yes.
Okay.
That is the Spanish chili. I don't like chili. I think it makes sense that the certain.
Which would mean that across the hall, it's corny. Spear's the master of dad jokes. You think my jokes are bad. What was the base? 5/8. So I call this 5/8 squared. I gotta write it as 5/8 again. They're cubed, and it was flipped, so -3. Okay. So, once you got that base taken care of, it's just basic algebra. 6x plus 2 is -15 plus 12x. Get -6x. Get -17. X is gross.
It should be 6x.
-6. Oh, I just can't read my own handwriting. Yeah. I just can't read my own handwriting. Went too fast. So that's -13 now. Notice that when actually to me, she was even. Yes, 13/6. Okay. So, having seen an uglier one, would you be okay if you just randomly saw stuff with big numbers on them now? Well, I usually make the mistake now, and then I remember to not make the mistake then. Yeah. You're ruining my statement and feeling superior. What? I said your hair looks nice. So, move on to the next one. I used that on my wife so many times, she just started punching me when I said it. Logarithmic equations. These ones are all going to be based off the definition. We're not at the one-to-one property yet. This is just straight up definition. What's the base on this? E. Okay, this is log base E. And the definition says this to this power equals object. So x is just e to the sixth. That's my answer. Now, if I tell someone that I have e to the sixth of something, they're going to go a little cross-eyed and grunt at me. So now give me the decimal approximation with it. What 103? 403. Okay. Okay. Like, that's it. That's how you do this. And then we start adding to it. We start putting a little more on there each time. In order to use the definition, you have to have just a log. Log of thing. I'm not at log of thing. So who has to go away first? Okay, so I subtract 6. Then before going to exponent town, well, you know what? I'll do it both ways. If I put that up in exponent land, what does the 2 touch? The 5 and the x. Which gets me, what's the base on this? So 25x squared is 10 to the 12th. That's going to be a really big number, yep. So how about this? Before dividing, could I square root right now? Right? That's plus or minus 5x is plus or minus 10 to the 6th. I put the square root there. Well, okay, when I have a plus or a minus divided by a plus or a minus, I'm just going to end up with a plus or a minus, right? Okay. No. Square root is 1/2 power. Wait. So I'm just saying it's going to be plus minus on both sides, so you're good to go. Divide by 5 and you get plus or minus 2 times 10 to the 5th, because I'm just taking one of the 10s divided by 5, which is 1, 2, 3, 4, 5 zeros, 200K. Divide by 5. I broke this into 10 times 10 to the 5th so that I could mental math it. You can just grab a calculator. So I get plus or minus 200,000. Look at the original. The original equation has a logarithm in it. Thou shalt not log of non-positives. So it has to be only the positive 200,000. Now, Another way, see how we ended up with 2 answers, but one was extraneous. We're going to feel kind of silly now after all that work. Couldn't I just divide by 2?
You have to absolute value the x. Oh, you're right.
I mean, technically, yes, but I'm going to end up with a positive version anyway. If you had absolute value of x, that just means you'd have to do light side, dark side. So you'd have a negative version of plus minus and a positive version of plus minus, getting 4 answers, but 2 of them are positive, 2 of them are negative. The negatives cancel out because they're not legal, and the positive ones are the same. So you can do that. But, yo, look if you just divide by 2. How much faster does this get?
Why do you take us on this back road?
Someone said move 2 up to exponent town, so I did. I was just driving. The person behind me said, okay, take a left. Do you see how you get the same answer, though? And in this case, you only get the positive answer. This is why I strongly recommend that if you can, divide instead of going to exponent town so you don't have to deal with that. Case in point, look at the next one. Instead of going 8 to the 12th and then doing the cube root of that, I'm going to bring this out front, divide both sides by 3, getting log base 8 of x is 4. Instead of dealing with 8 to the 12th and having to cube root that, I'm just going to bring my 3 down as a coefficient and divide by it. It is 4096, yes. Lori, sorry. 8 to the 4th. Okay. Is that a legal answer?
Yes.
Okay.
If it was negative and there was a cube root, would it ever not?
What's a negative to the cubed power?
To this second power.
Then it might be legal. Okay. So yes, because we have logarithms, we're going to need to check for extraneous solutions now.
Would you ever get an answer where it doesn't work?
Yes.
Even though how do you do legal and positive?
Yes. As long as you have a logarithm in the original equation, you have to check. Go. You got the properties, you got the tools. Mess around with them however you feel like. Just make sure that you double check your answers at the end. Those are not the final answers. I'm just waiting for folks to catch up because I hear good conversation.
Which is 5 over that.
No, dividing by 5 is the same as multiplying the denominator by 5.
Right. So
It's just 1 over 50,000.
So it's a really small.
It's 1 over 50,000.
But can you put it in decimal?
No. Okay, it is a terminating decimal, but you better have the entire decimal train there.
Is it like that?
The last one was yeah. Last one that one we just divided by 5, so then it's 2 with a negative 4. Yeah. Because on the one like right above it, it's divided.
Oh no. My mental math, I split a 10 off of it. And if I split a 10 off of it, that means now this is 10 to the negative 5th. Right? Because 1 plus a negative 5 makes negative 4. Then if I want to divide this by 5, okay, that's 2 times 10 to the negative 5th. That means 1, 2, 3, 4, 5, 0.00002, which is 1 over 50,000. No, I'm saying because of this exponent, you can't just divide 10 by 5. Because of the exponent. Because of the exponent. Okay. All right, x is 1 over 50k, or 0.00002. And can I have a positive and negative radical on that last one? What happens when I take a negative radical and square it? Yeah, I get a plus or minus square root of 82. Am I allowed to put the negative root of 82 in here? Because I'm going to square it, it's going to end up with a positive value, so that is legal. Okay, be a good place to start with tomorrow. I said 3-4 is usually a day and a half. Okay, so we'll start tomorrow with a little bit more of this stuff. I'll make sure that your assignment doesn't go any further than log definition equations. If anyone owes me tests, I think there's like 3 or 4 of you. Be a good day to get them done.